Welcome to today's paper reading. Today's paper is titled MedGraphRAG, Towards Safe Medical Large Language Model via Graph Retrieval-Augmented Generation. This paper was published on the AR14 preprint by Junde and colleagues from the University of Oxford. The authors introduce MedGraphRAG, a novel retrieval-augmented generation framework tailored for the medical domain. This framework aims to enhance the capabilities of large language models by generating evidence-based results, thereby improving safety and reliability when dealing with private medical data. The framework begins with a hybrid static-semantic approach to document chunking, which significantly improves context capture compared to traditional methods. Extracted entities are used to create a three-tier hierarchical graph structure, linking entities to foundational medical knowledge. This structure supports precise information retrieval and response generation. The authors validate their approach through a comprehensive ablation study, demonstrating that their hierarchical graph construction method consistently outperforms state-of-the-art models on multiple medical Q&A benchmarks. Additionally, the responses generated include source documentation, significantly enhancing the reliability of medical LLMs in practical applications. The rapid advancement of large language models, LLMs, has transformed natural language processing and AI applications. However, LLMs face challenges in specialized fields like medicine due to complex deployment and potential for hallucinations. Retrieval-Augmented Generation (RAG) addresses these issues by using specific datasets without model retraining, but it struggles with holistic understanding. The MedGraphRAG (MedRAG) method improves LLM performance in medicine through a three-tier hierarchical graph construction and a U-retrieve strategy, enhancing transparency and interpretability with intrinsic source citations. The methodology of MedGraphRAG involves several key steps to enhance large language models with a specialized medical graph. Firstly, document segmentation is performed using a mixed method of character separation and topic-based segmentation, ensuring context is preserved. This includes proposition transfer for semantic chunking and a sliding window technique to maintain topic consistency. Secondly, element extraction is conducted where LLMs are prompted to recognize and detail entities, including their names, types, and descriptions. This process is repeated to enhance quality. Lastly, hierarchy linking is established through a three-tiered RAG structure, connecting entities to grounded medical knowledge from sources like UMLS, and identifying relationships between entities using predefined descriptors. Figure 1 provides an overview of the MedGraphRAG framework, which is designed to enhance large language models, LLMs, in the medical domain. The framework involves a three-tier hierarchical graph structure that links entities from user-provided documents to foundational medical knowledge. The U-retrieve strategy is employed for efficient information retrieval, combining top-down retrieval with bottom-up response generation. Metagraphs are merged based on semantic similarities to form a comprehensive global graph, ensuring precise and contextually relevant medical responses. In this experiment, the data is structured into three distinct levels. The top level includes private user information, which is updated frequently. The middle level consists of peer-reviewed medical literature, updated annually. The bottom level contains authoritative medical vocabularies, updated every 5 years or more. For the top level, the MIMIC4 dataset is used, covering patient admissions from 2008 to 2019. The middle level employs the MedCK corpus, which includes 4.8 million biomedical papers and 30,000 textbooks. The bottom level utilizes the UMLS dataset, which unifies over 200 medical vocabularies. The test data includes PubMedQA, MedMCQA, and USMLE datasets, each serving different purposes in evaluating the models. Figure 2 compares the performance of MedGraphRAG with state-of-the-art, SOTA, medical language models on the MedQA benchmark. The results indicate that MedGraphRAG, when applied to GPT-4, surpasses the previous SOTA model, MedPrompt, by a significant margin of 1.1%. This performance improvement is notable as it demonstrates MedGraphRAG's effectiveness over models that have undergone intensive fine-tuning. The figure highlights MedGraphRAG's achievement of the SOTA on the MedQA benchmark, emphasizing its superior performance stemming from leveraging the robust capabilities of GPT-4 without the need for costly fine-tuning. Table 1 illustrates the enhancement in performance of various large language models, LLMs, when augmented with MedGraphRAG. The data shows that MedGraphRAG significantly boosts the accuracy of LLMs on medical benchmarks, particularly benefiting smaller models like Llama 2-13b and Llama 3-8b. This improvement is attributed to the implementation of zero-shot RAG, which is more efficient and convenient than traditional fine-tuning methods. Additionally, MedGraphRAG aids larger, closed-source models like GPT-4 in achieving state-of-the-art results, demonstrating its broad applicability and effectiveness in enhancing clinical AI performance. Table 2 presents the results of an ablation study on MedGraphRAG, focusing on document chunking, hierarchy graph construction, and information retrieval methods. The study reveals that the hybrid semantic method significantly enhances performance compared to a purely static approach. Additionally, the hierarchical graph construction method outperforms the base graph construction method, indicating its effectiveness in improving RAG performance. Lastly, the uRetrieve method demonstrates superior performance in enhancing retrieval accuracy and relevance over the summarized retrieval method. This paper introduces MedGraphRAG, a novel graph-based retrieval-augmented generation framework designed to enhance the capabilities of large language models in the medical domain. The framework combines advanced document chunking with a hierarchical graph structure, significantly improving data organization and retrieval accuracy. Ablation studies have confirmed that MedGraphRAG outperforms state-of-the-art models on medical Q&A benchmarks, providing credible, source-linked responses that are essential for medical applications. Moving forward, the authors aim to expand this framework to include more diverse datasets and explore its potential in real-time clinical settings. Figure 3 demonstrates how MedGraphRAG enhances GPT-4's responses to medical questions by providing evidence-based answers with grounded citations and simplified medical terminology. In a case study involving a patient with symptoms commonly associated with Alzheimer's, MedGraphRAG accurately diagnoses vascular dementia and offers detailed, verifiable explanations, making the information trustworthy for clinicians and accessible to non-medical users. Thank you for watching.